Hi everyone. We're here today to look at round elbows. Now I've drawn one on the board here, and this is a very common parallel line development project that we'll see in sheet metal work. So this one, we're going to just look at a few parts of it before we get into the layout of it. So in this case, we're looking at circular elbow, just like this one here. Okay, this particular one is 90-degree elbow. We have a diameter or size of it, and we have 4 pieces in this case. We can have multi-piece elbows. They could be anywhere from 2 pieces all the way up. The more pieces there are, the more work it takes to actually construct it and to lay it out. But you'll see something like this. I've drawn a 3-piece on the board. This one's a 4-piece. Okay, we're going to look at a few of the parts to that. So right now we have piece 1, piece 2, and piece 3. Now the first step in any elbow calculation or layout is to find out what this angle is in here. And if I drew these lines in here, what is the angle in here? Now we can't merely divide it by 3 because these angles aren't the same, because the pieces aren't the same. Okay? And that's our first step when doing any layout, is what we refer to as the elbow rule. Very important. The elbow rules lets us establish everything else in our layout, so it's really a building block. So what the elbow rule is we take the number of pieces we have and we multiply it by 2, or we double it. So we say it's pieces times 2, and then we minus 2 off that afterwards. Minus 2, and we could put a couple of brackets in here to make sure that we know where we're going with that. Now the reasoning is, if we look at the individual pieces, we can see that there's a difference between the 2 end pieces and the middle. Okay, and the difference we see if we pull those out is the ends, and this will always be the case on every end. We have a piece that looks like that. Okay, and what we end up with there is one piece that's flat on one side and one piece that includes a miter. Okay, but if we look at piece 2, the middle piece, it's different. So let's label this one end. But our middle will look like this. And it doesn't matter how many middles they are, they will all look the same. Middle. And the difference between the middle, 2 miter lines. Miter, miter. Okay, we don't have the flat end anymore, and you see that here. That one's perpendicular to, if we drew up a center line. This one, this cut is perpendicular to that. This one has 2 mitered lines. It's attached on both sides. So what we're doing in a long way around from this is we're going to double everything, because we know that all the middle gores are actually cut here. Then we could say those are all exactly the same, because this straight cut would be the same as if we did a straight cut here. And we separate those 2 out, and we end up with 2 of these. Okay, so we double everything, but knowing that each end is already what it needs to be, we minus the 2 off. So we're minusing something that would have come off here, like that. And same thing here, we would have had one come in like that. We're minusing those off. So we double everything, and then we minus 1 each for the ends. Okay, and what that gets us to is what we call gores. So this equals this whole thing. This is called gores. How many gores do we have? We had 3 pieces. I'll leave that. So 3 pieces equals 4 gores. So if we go through, we can say that here's a gore, here's a gore, here's a gore, and here's a gore. Those are all gores. And they're all exactly the same now. There's no variance between the ends. Okay, so that's our starting point, is to establish how many gores, sometimes referred to as segments. Okay, but what we want to see is when we get a visual or a drawing of some sort, or some pieces the elbow is, the pieces aren't what we further calculations with. We have to find the amount of segments or gores as we refer to them. Okay. So now we know how many gores we have. We can keep going with our elbow. And what that allows us to do, now that we know that all of these are the same, and they're all including a miter line and a straight cut. And this is an imaginary straight cut. We could do it, but then it's just more work for us. So why bother? So we leave it alone. But what it does tell us is now all these angles are all the same. So now we have 4 gores, and we have 1, 2, 3, 4 angles. And if we know this total angle is 90 degrees, we can divide it through. And that gives us 2, that's 8. Bring that down, that's 1, that's 10, that's 2 again. With 2 remainder, drop that down to 0. And 22.5 degrees. Okay, so if we divide the number of gores into the angle of the elbow, it gives us what we refer to as the miter angle. 22.5 in this case. So we went 3 times 2 is 6, minus 2 is 4, and 4 and 90 gives us 22.5 degrees. So that means that each of these angles, 22.5 here, 22.5 here, 22.5 here, 22.5 here. So you can see now why we needed the gores, because now all our angles are the same and each piece is a repetition of the last. Okay, so if we have a list here, 1, we found the number of gores we had. Number 2 we did is find the miter angle. Okay, so let's look at what we do next. Okay, the next thing we're going to do is work on and calculate out our blank size. So how big a piece of metal it takes the entire elbow. So that's going to be a rectangular part like this. Okay, our circumference or our stretch out is going to be the circumference here. So that one becomes pi d. We need to find the height. We can't transfer anything like we did for our t's, and we don't have a calculation that comes right off of an elevation view. We have to do a bit of calculation. Now, if we look at our sample, we'll see something here in the construction of this elbow that each piece, we want this seam to go opposite. Okay, and we put the seam on center so that we can do that. Seam here, and then it rotates to 180 degrees. And then the seam's back here, and then the seam rotates again. So that we don't have an alignment of seams, which will give us air leakage. Okay, so the center point of the piece or the gore is where we want to put our seam in this case. And that height repeats itself on every gore, because remember, every one of these is now the same. So if we were to look at a line on center that came up, we know that that line here is going to be the same as this one, the same as that one, and the same as that one. Those are all equal. And because they're on center, if we actually spun that elbow, if we turned all the parts so that they were aligned, we're moving the heel section around, and what it does is it wouldn't take long. It would go long, and they would rotate. That would make it a straight piece of pipe. Okay, so what we can do is transfer and sort of visually look at it, that if I had one elbow gore here, and then I spun the next one so that now my long side is on the opposite, would go like that. And then the next one. And then the next one. Okay, so if we aligned them that way, which we're not trying to do, but if we could, and we'd make it just a straight piece of pipe. But when we look at it that way, if we go back to our center line here, here's my center line here. And then I know, remember this is cut actually. These are two gores. And they both have a center line. And so does this one, and so does this one. And those are all right across here. So now by no means is this to scale for the one we're doing, but it gives us a visual representation that I'm going up the height of the seam here, and then I do it again, and again, and again, and again, and again. Okay, that's a 4-piece. Like our sample, we've just done a 3-piece, but what we know is we're going seam height once, twice, once, twice, 3, 4 to get our 4 gores up. So if we took and measured this distance and then multiplied it by 4, that would give us our height here. So in this distance, this becomes our seam height times number of gores. Seam height, we got 1, 2, 3, 4 of them. So our third step here is calculate the blank size. And we do that by circumference in one way, plus any allowances we need on there. This way, seam height times number of gores. Okay? Now when we look at that, just go take a step back for a minute. We know that this is 22.5 degrees. And we know this distance here. That we refer to as our center line. So from the start of the elbow, where the radius occurs, to the center of the opening. That's our center line. We know what that distance is. We can calculate this out by use of trigonometry. Okay? We have an angle. We have an adjacent side. This would be an opposite side. So that would be a tangent function. We could quite easily calculate that out. But we could also just draw it. If you ever get stuck, we don't have to use math, and there's a lot of math we can use in layout. But in any case, we don't have to use it. We can go backwards and just draw it and then measure from there. So draw the gore, measure the seam height, multiply that by the number of gores you have to get our height here. Okay. The next step is to do our layout. Okay. If we're in the shop, we're going to go cut that blank size. I'm going to draw it out here, and then we'll further on with how we lay out that part. Okay, so I've drawn out my blank size now, and I've got, I took my seam height times the number of gores I have to get my height, and I took pi times diameter this way. Keep in mind, if you have any seam allowances to add on there, they will be beyond your circumference, and they will be outside of your 12 divisions. Okay, you don't want to make the mistake of calculating it out, adding your seam allowances, and then dividing the whole blank size by 12. The seams will not be in our divisions. Okay, so our first 3 steps we did are really the starting point, and really we don't need anything else but the size of the elbow, and then the number of pieces it is and the angle. And then we can do all those calculations. We don't even have to draw anything yet. So let's just say that we're in the shop and we did those calculations sitting at our bench with the known numbers we had. We cut a piece of metal, we divided it by 12, and here's where we are now. Okay? So what I'm going to do is I'm going to draw out my end gore to get the rest of the information I need. So I'm going to come in and I'm going to draw my base here, and I know those are going to project up from there. Now these may or may not land on our 12 divisions. It's just a fluke if it does. Here's my radius point here. Okay, and then I'm going to set my divider here, my arm to our miter angle, and I project off that radius point until it comes through my gore. Okay, and there we go. We got part 1 drawn. There's not much to the drawing of a elbow gore. It's really a piece of pipe on a miter once we have all the other information we need. Okay, so again, I'm imagining I'm in the shop with a piece of metal, and if I do that, I don't have anything below down here where I would scribe my profile. Okay, so I'm going to set to my radius, and I'm going to swing that profile. But like I said, I don't have, maybe I have some bench space to do it on. Maybe I do, maybe I don't. But again, it goes back to some of our work on T's, that when we're doing a profile, it doesn't matter where this height necessarily is, okay? Because we're not going to gain those numbers off of that. If I put the profile way up here and then projected it into the miter line, I'm still going to hit the same spots. Okay? All they're producing is a vertical line, so it doesn't matter where it is in here. So, with that being the case, I'm going to do it right over top of my view here. And I'll divide that. Bring my center line up. That one's just going to carry right through, so I'll bring it right up here. And finish my divisions. And now I'm going to bring those up into the miter line. Again, they'd be in the exact same spot if I drew it below. It doesn't matter. There we go. Profile, divide the profile, bring those element lines into the miter line, and then those become my horizontals, is going to be these points here. Again, circle them, don't draw over top of them. Circle them so you keep your accuracy. Bring all of these across. Now we'll start to see here as well, we have some symmetry on an elbow, left to right of the center line. Now one goes up and one goes down, but the spacings and the characteristics other than their direction are the same. And we'll see that in a second here. Let me just bring this line out a bit to give some clarity. So if we look from center and we got a fairly large space here, and then it gets a little narrower space and then narrower again. And it's the duplicate down, larger, narrower, narrower. If we took the space between these two outside ones here and measured it, it would be exactly the same as it would be here. Okay, so we have 3 lines there. We have 1, 2, 3. 3 distances, I should say. And the match of those distances are on the other side of it. So this is the same, that's the same, that's the same. So whatever it does up, it does the same thing down. And we can see that from center here. If I maybe bring this over, and if I created 2 little triangles in there, you can see we have this triangle here and this one here. Same above the seam compared to below. Okay, now this one's going to follow our standard parallel line pattern as far as it's going to go over one, down one, or over one, up one, until it hits the top, and then it'll go all the way back down, or vice versa. So we just choose where we want our seam, and we said that we always want it on center. So that's our center line. So we're going to start here, and then I'm going to go over one, up one. That gives me a point here. And then over one, up one. That gives me a point here. And then here. I'm all the way to the top, so I come back down to here, to here, to here, to here. And we end again at center line or our seam, so we get the true pattern. To further that pattern, if we're in the shop, we're going to cut this gore out, and then we're going to flip and trace it. But what we want to do to help us with that is take our dividers onto our seam height, there's my seam height there, and I'm going to knock that off however many times I need to, and it's a good idea to draw those lines in. We're not going to cut on them all, because we know that the middle gores include 2 seam heights. So we'll have 1 seam height on the end and 1 seam height at the end, and then the middles will include doubles. There'll be 2 of them in here. And then to get our seams staggered so that they're orientated that way, if we go up on this side here, and if I draw that in, we're going to go like that. We always want to produce what we refer to as our fish pattern for an elbow. Because we want the seams back and forth, we don't want them in a line together. Our next one is going to go opposite this one. So I'm not going to draw it all in, but it'll give us an idea of which way we're going to go. And we're going to come down instead of up there, like that. So we're coming in this way and in this way, so we get a very narrow point here. And then we go out there and out here, so we get a really wide point here. And if we look at that, just that one section is what we see as our fish. Put an eye on it and a little smiley face. There's our fish pattern. We've got the tail down here, the head up top. Flip and trace to create the rest of our pattern. Once you have your blank size, everything will just work out. And that's how to make a round elbow.